Review question number 1. What is the point of concurrency for the perpendicular bisector?
Oh, I know what that means.
Somebody just answered it like 3 minutes ago.
Are you sure? Well,
Raise your hand on this one.
do you want me to answer?
It's the circumcenter. So you have to understand that the perpendicular bisector and the circumcenter go together. Okay? Okay, so that's just a review. Today, we are going to talk about the angle bisector.
Cool.
I know, you're super excited about this, aren't you? Okay, its center, we're going to learn later on in the unit, is the in-center. Okay, in-center. I'll try and the reason is because you are going to see later on that the circle is inside the triangle rather than going around the triangle. Okay? All right, so we'll do that a little bit every day, just kind of review so that we know which one goes with which. Okay? There's 2 more lines that we have to learn and 2 more centers that we have to learn. Okay? All right, so the angle bisector. All I'm going to do is I'm going to draw a picture similar to what you see under example number 1. I am going to draw an angle, and then I am going to cut it in half. Okay? So an angle bisector means that this angle is congruent to this angle. Okay? If I have a point on the angle bisector, it is equidistant to the sides of the angles. Okay? But we like to have that little right angle symbol there, similar to what you see down here in example number 1. Okay? All right. So, what we are going to learn about the equidistant part, okay, is, can anybody tell me or give me a reason why that top triangle is going to be congruent to the bottom triangle based upon what you see right now? I heard AAS. Where's the S? Reflexive. Okay? So he says AAS. Do you agree with them?
Yeah.
All right, so those 2 triangles are congruent. Why are the 2 red lines congruent now?
Because they're both right angles.
CPCTC. The corresponding parts are congruent because the triangles are congruent. Okay? All right? So that's the idea that we need to understand. So the theorem, okay, if you would like, I can write it down. Okay, I can put it into words, but it simply talks about the idea that, okay, any point on here is equidistant to the sides. Okay? So what that means is if I were to choose a different point, like this point, as long as we have this angle being a right angle, and if I were to draw it this way and this angle being a right angle, now these are equal to each other because they're equidistant. Okay? Do we need to write it up as a phrase?
No, you do that.
Wait.
Visual
we're
learner?
good.
We're good? I'm never going to ask you to write down the theorem. You just have to be able to apply it. Okay?
We're gonna have to do proof.
We are pretty much done with proof. So like what we're going to do now, okay, like we just did a proof like 2 seconds ago. Okay, Elliot explained that this triangle was congruent to this triangle by AAS using the reflexive property. So he just did it all mentally. Okay, so I'll just keep asking why the things are congruent, and as long as you can explain, we don't have to write it all up.
Okay.
Okay? All right, so in example number 1, okay, based upon the concept of the angle bisector theorem, okay, it says that if this is the angle bisector, you should be able to figure out what x is equal to.
27.
X is equal to 27, okay? Now, if you didn't know that was the angle bisector, there is enough information to prove the top triangle congruent to the bottom triangle because of your right angles, and 15 is equal to 15. Why would the top triangle be congruent to the bottom triangle? not A, not AS. How about reflexive? And now the two triangles are congruent by HL, okay? And now the two angles are equal to each other because of CPCTC, okay? All right? All right, down here. This is going to be a toughie, okay? Very good, okay? We are going to, okay? So they're telling us that this is the angle bisector. They didn't put that in the directions they should have. Okay, so that's the angle bisector. We got the perpendicular, so therefore Philip is correct. We set them equal to each other. 6x squared minus 7x plus 10x, oh, not plus, equal to, sorry, equals 10x plus 3. All right, the reason why I said this is a toughie is because we got to be able to solve this x squared, quadratic equation. Okay? Do you recall from chapters 9 and 10 last year how to do this? We're talking about chapter 9 and chapter 10 from 70-71.
Wait, I forgot.
Oh.
Make us proud, kid.
4 years.
So, add 7x.
Oh, you already know.
Okay, keep going. I need to know what you would do next.
Subtract 10x.
Yes. We do 6 in the first semester and 5 in the second semester.
Is that more than last year?
No, it should be about the same. You guys got through at least 10. Did you get to rationals? Concept that you need to know is you have to set equal to 0. So that means I got to subtract 10x and I got to subtract 3. So now I've got 6x squared minus 17x minus 3. Okay? Then you should have learned, and I just talked to Mrs. Hope about this, the splitting the middle term where you use the earmuff method. She might not have called it the earmuff method.
We never learned this.
Okay? So, I need two numbers that multiply to be the product of the earmuffs. Okay? So, multiply the earmuffs together. Tell me what you get.
Nothing.
What's 6 times negative 3? That's nothing? Negative 18. Okay? Then, I need two numbers that add to be the middle term, which is negative 17. Okay? So, can anybody come up with two numbers that multiply to be negative 18 and add to be negative 17?
I don't know. Really hard. This one's too much. 9.
I told you this is a toughie.
Negative 18 and positive 1.
Oh, negative 17.
Okay? Jesus said negative 18 times 1, and then negative 18 plus 1. So the reason why we do this is just a little check here. Okay?
Wait. This is part of it?
Yep. We're about halfway. Okay?
What is that negative 18?
All right, so the reason for that is now we split the middle term into two terms. The earmuffs stay.
I remember this now. Qué horror.
You have to translate that.
All right. So you need to be able to give me the GCF of the first two terms. Well, that's what GCF stands for. What is it?
She's asking what is it?
Oh.
Are you just sure?
So you're gonna tell the class? What number?
Yeah.
Okay, that's fair.
Doesn't 6 go into 6, 6 goes in 18?
Yes.
Don't they both have at least an x?
Yes.
So if I factor out a 6x, I'm left with x minus 3.
I'm running out of room.
What do you factor out of x minus 3 to keep it x minus 3?
The 1.
Correct, positive 1. Your GCFs come together to form a parentheses.
Oh, I got this. Yeah.
So
I remember like most.
Okay? All right, so now the last part. The x equal to. What does x equal to?
It is.
Do you remember this part?
Do you multiply the?
Nope.
Oh no.
If you multiply it, then you get back to where we started, and then we got to start all over again. Nope.
You subtract.
You
Is
leave
that
it.
right?
Did you learn the idea that it's simply the opposite?
Yeah. X equals 3.
So if it says negative 3, then the answer is positive 3. If it's positive 3, then it's negative 3. Okay? Okay? Did he do swing method? Well, you said there was a different way. So, well, you can do that method if there's not a number in front of the x squared. When there's a number in front of the x squared, you have to do it this way. Or you can do the swing method. We could show you a different way. But then, did you do it with the fractions where the dividing?
Yeah, I like that way.
Okay, that's swing method. So, okay. All right, so reminder, notes usually are tougher. Homework questions are usually tougher. You won't have one like this on the quiz. But it looks like it's something that we might need to add to our algebra reviews. Okay? All right, example number 3. You have to decide whether or not, okay, QS is an angle bisector.
No.
Is there enough information?
No.
No. Because even with reflexive, how many congruents do we have? 2, and we need? 3. All right, so remember, you got to be able to show that the triangles are congruent in order for it to be an angle bisector. If you wanted a different way, and if you're not good at like figuring out the HL and the SAS and all that stuff, okay, here's your little checklist, okay? And you always need 2 out of the 3 in order for it to be an angle bisector. Number 1, you need the perpendicular angles, and it has to be perpendicular to the sides of the angle. Number 2, you need the opposite sides congruent, and that means the sides opposite the angles. So that's like PS and SR, okay? Number 3, you need the bisected angles marked congruent, okay? So if you have 2 out of those 3, you can always assume the third, and it's an angle bisector, okay?
I thought you said never to assume.
But I'm telling you, if you have 2 out of the 3, how about instead of assuming, we can conclude the third. How about that, okay? All right, I'm going to come back to it in a second, okay? So if I go back to example number 1, okay? I've got 2 out of the 3. I've got 15s, so the opposite sides are congruent, and I've got the perpendicular angles. So now I can conclude that x is equal to 27.
Yes.
Okay? So if I come down here, I've got the angles marked congruent. I've got the perpendicular angles. I can conclude that the sides opposite are congruent. Okay? I come down here, I have the opposite sides marked congruent, and that's it. I only have 1 out of 3, so therefore I cannot assume that QS is the angle bisector, or conclude instead of assume. Okay? Does that make sense?
Yes.
All right, so on this one, on the next page, angle bisector, yay, nay?
Yay. Yay. Oh, wait.
I only have 1 out of 3, so that's why it's no. Over here, I've got 1, okay, from the sides opposite, and then I've got the angles, so therefore I can say yes. Okay? Eventually it would be HL if we, so you can go back to proving the triangle is congruent by HL, correct?
Yes.
Okay? All right? So again, just like yesterday, you either go to the idea that you can show the triangle is congruent, or you can now use the idea of the checklist. Okay? All right, so we already talked about this a little bit, and that is the three angle bisectors of a triangle intersect at the
In center.
center. You see it in the big letters there. Okay? This point is equidistant from the sides of the triangle. All right, so these lines with the arrows, okay, these are the angle bisectors. They're bisecting the angles of the triangle, okay? So what I'm going to do is I am going to move this so that it looks like, so if I take this, okay, and we only look at this part of the triangle, does this picture look like all the previous examples that we did?
Yes.
Okay, and we just said that this is an angle bisector, so this is congruent to this, okay? All right, so what it is saying is that this line here is congruent to this line here. Okay, and that's those opposite sides, the sides opposite the angles, right? Okay, so if I go back out, if this red line on the left is congruent to the red line on the bottom, what's true about the red line on the right? It's also congruent. What are all three of those red lines in comparison to the circle?
Radius.
They're all the radii of the circle, so therefore they're all equal to each other, correct? Okay? So notice that all those red lines are starting at the center, the in-center, and they're going out to the sides of the triangle. So that's the part where it's saying it's equidistant to the sides of the triangle. Questions there? All right. So would you be able to agree that these triangles, so this triangle is congruent to this triangle? Yes?
Yes.
Okay. So then if those triangles are congruent, would you agree that this side length is congruent to this side length?
Yes.
Okay. So then if I go up here and I look at these triangles, would you agree that this side length is congruent to this side length?
Yes.
Yeah.
Okay? And if I keep going and I look at this set of triangles, that this side length is congruent to this side length.
Yes.
Everybody good with that? Okay? All right, so now to compare to yesterday. Yesterday, we said that this length was equal to this length. Now we're saying that the lengths are on two different sides of the triangle. So to compare the two, okay? You know, if you simply look up here, like, will you say that this length is equal to that tiny little one at the top?
Yes.
No.
Oh, no.
Okay, so therefore, those dots on the sides of the triangle are not the midpoint or the perpendicular bisectors anymore, okay? But these are still perpendicular, these are still perpendicular, these are still perpendicular, okay? All right, again, kind of going through this, you have to kind of picture it a little bit. Big property that you simply have to know is that the sides on both sides of the vertices of the triangle are equal to each other. Okay, and then you have to understand that these lengths are all equal to each other. So now what we're going to do is we're going to, okay, all right. So this one, okay. Can anybody tell me what the length of EA is? What is it?
10.
Okay, Julia says 10. What do you guys think?
Sure.
All right, so we just said tick, tick, okay? The two sides on both sides of the vertex of the triangle are equal to each other, okay? All right, there are two side lengths that are equal to 13. NE is one of them, and ND is the other one, okay? Because here is your circle. Note it is inside of the triangle. That's your in-center. So now these three red lines now become your radii. Okay, so over here, can anyone tell me what EA is equal to?
16.
16. There are two, no, let's see, so next, all right. So we need to figure out what NE is, and NE is equal to NF, which is equal to ND. How can we do that?
Easy. A squared plus B squared equals C squared.
Good job.
Whoa.
Okay, so he's looking at this triangle, and he sees, oh, that's a right triangle. Okay, so now, smarty pants over there, okay, which one is the C?
20.
Very good. Okay, so now we've got 16 squared plus B squared equals 20 squared.
I can do it this time.
You want to do it right this
I
time?
got this.
Okay, all right, tell me what you
Let's do
get.
it.
No, everybody's going to do it and check your answer.
You subtract 400 from 256. No, other way around. 400 minus 256 equals 144, and the square root of 144 is 12.
Okay, so B equals 12. Okay, all right, so now, what's the length of NF?
NF is
12.
What's the length of ND?
12.
Ah, there you go. Okay, all right. So remember, big idea you just have to understand is the sides. So like BF is congruent to BD, CD is congruent to CE. Okay, that's the idea. Okay, apply that.